let's run through that. Some of you said you were a little confused on it, so let's run through the homework. We'll go step by step through it. Of course, you could do it on the calculator. I'm going to do this one by hand, if that's okay, because I'm pretty sure you'll know how to do the calculator later. So I think this is what I have planned today. So we're going to do 3-3. We started 3-4 yesterday. So I'm going to go through the worksheet on 3-3. And then 3-4 we started. I'll finish up on 3-4. And then I'll do that. And then we'll do 3.5 we'll do on Monday. You have a take-home quiz over this weekend. And then after Monday, then Tuesday we'll review, and then we'll test on Wednesday. I think that's what I will do. Of course, I'll probably change that between now and then. All right. Excuse me. So problem number 1. I'll do the first one by hand, then the rest I think I can do a calculator. So we have the values 1, 2, 5, 8, and 9. So it's very similar to what the example was. If I were to find the average, is everyone comfortable with finding the average? Anyone not? So we add them all up and we divide by the total number. So we're going to find the average to be 5 in this case. Okay? And then if I do x minus x bar, so x meaning the value, what I'm going to do is I will have some positive numbers and some negative numbers. And we said that the positive numbers are to the right of the average and the negative numbers are to the left of the average. Is that right? So if I go 1 minus 5, I get negative 4. 2 minus 5, I get negative 3. 5 minus 5, I get 0. What does 0 mean? Because 0 is not positive or negative, is it?
Wait, but don't you do outside parentheses? Wait, never mind.
Not yet.
Yeah, that's the next thing.
8 minus 5 is 3, and then 4. So if these are to the left of the average and these are to the right of the average because they're positive or negative, what does 0 mean? It does cancel out, so what does it mean? It's the center, so it's the average. Okay? So the 0 just means you're at the dead center of your data. Okay? Remember, 0 is a signless number. It's not positive, it's not negative. It's the fulcrum in between the two. But that's what it's taking place. And then after that, we do x minus x bar quantity squared. So remember, these are in parentheses, so anytime I square something that's in parentheses, it always comes out to what kind of number? Positive. So I get 16, 9, 0, 9, and 16. Is that okay? And then we created this. So sigma, the Greek letter, means what in math? The summation, right? Yeah, we're going to add it together. So I'm going to go 16, 9, 9, 16, and 0. Add it all together. And that'll give me 50. And then, excuse me. And then we just have to do what we're told on it. It says, the next step, we want to do the summation of x minus x bar quantity squared divided by n minus 1. So this is a sample, so we're going to do n minus 1. And they're telling us to use n minus 1 on this one. So what does n represent? Yeah, how many numbers are actually in the data? So how many numbers are in our data originally? 5. So we're going to take this. This is the numerator. So that's 50. I'm going to divide it by 5 minus 1, which is 4. So that's going to come out to 12.5. What did we call that? Variance. Good. Okay, so variance is that. If I take the square root of 12.5, what's the square root of 12.5? 3 point what?
What's the square root of 12.5?
3.5? Exactly? 3.54. Perfect. So the standard deviation is then 3.54. Okay? What do you think? So from here on out, because my calculator doesn't work all that well when I stand at the board, so I'm going to pull up the calculator and go through it. So problem number 2, which data would you expect to have the biggest standard deviation and why? Any ideas? All right. Let's walk through it. Stat. If we hit stat, we hit 1. If I have something there, I go up to the top, highlight L1, hit clear, then down arrow, it clears out the data. So I'm going to plug in letter A for L1, letter B for L2. Is that okay? So it looks like I have 1, 3, 5, 56 for some reason, 5, 7, 9, 11, 13, 15, 17, 19. And I'll go over to L2 and I'm going to put in 4, 5, 6, 7, 8, 9, 10. Thank you. 8, 9, 10. So, which of those data do you think would have the biggest standard deviation? The numbers that are all lined up in a row, Lenny? Or all the numbers that are spread out? Bigger standard deviation, take a shot. What has bigger standard deviation? If I have numbers that are spread out real far from each other, or if I have sequential numbers all next to each other, which one?
Spread out.
Spread out? So good. Hey, would you come to my office over there?
Can you say this office?
Sorry.
Can I come today? When?
I don't have anything. After this class, I'm over in that building for the whole day until I walk over to Jimmy John's.
There's gum on my desk.
You can sit wherever else you'd like that doesn't have gum on your desk. It builds your immunity, I know that. Okay, so Lenny says that the spread out numbers have a bigger standard deviation than the all sequential altogether numbers. Okay, so let's do this. I'm going to go stat, calculate. I'm going to do the one variable statistics. I'm going to tell it I want to do L1. And we're going to go down to, we have our sample, so we're going to use n minus 1. N minus 1 means that our standard deviation will be a little bit bigger. So 6.05. Is that about right? 6.06. That's for A. So if I go back to stat, calculate, and I do the one variable statistics, now I'm going to do it for list 2, because remember list 2 is there. And again, I'm going to do the larger of the standard deviation, so I get 3.03. So 6.07 or 6.06 for A, 3.03 for B. So linear right, the spread out has the larger standard deviation. Closer together your data, the closer your standard deviation will be. Okay? What does it mean when the standard deviation of data set is 0? That would be like this. If you flipped a coin 10 times and all 10 times you got heads, so there's nothing different about your data. Okay, you have the same exact result, so your number is the same. So if we found that, the average test score was a 70% because everybody got a 70%, that means that we're not going to have a standard deviation. We're dealing with the same data. Let's see. Problem number 4. On our vacation this summer in Hawaii, the high temperatures were, okay, can I plug these into the calculator? All right, so you guys need to see the key history. Go on large screen. Is that okay? It's like twice as big supposedly. All right, I'm going to go to Stats. I'm going to go to Edit, and I'm just going to clear out both of these. So go up to L2, clear that. All that data is gone. Go up to L1, clear that. And down arrow, that data is gone. And now I'm going to plug in the data. So I have 92, 88, 91, 88, 84. What did I do? Ooh. Oh, boy. Sorry about that. 95, 93, and 80. Okay? Find the mean, that's the average. Find the middle, that's the median. Find the mode, that's the most occurring number. Find the range, find the IQR. Wait a minute. Find the range, find the IQR. Let me do this real quick. Let's go. Stat, calculate, one variable statistics. Just for laughs and giggles, we'll say it's over list 1, hit enter. So we're going to find that the mean is 88.9 degrees, or 88.875. The median, well, if I arrow down, the median looks like 89.5. The mode, the mode is the most occurring number. So this doesn't always show the mode, but what you can do is if you go into Stats, and I'm going to sort into ascending order, list 1, and hit enter. This is going to, now if I go back to Stat Edit, my data is going to be in least to greatest order. So we're looking for the mode. The mode is the most occurring number. Looks like I have 88 that happens twice. So 88 is going to be the mode because that's the only one that happens twice. What if 88 and 91 both happen twice? What would it be called? Bimodal. Good. Find the range. Okay, so the range is going to be the biggest number, which is 95, minus the smallest number, which is 80. So 95 minus 80 is 15. And then they have something called the IQR. IQR. Why did we put the IQR? The IQR is the interquartile range. So with our data that we have, data calculate the one variable statistics. IQR is this. I'm going to go find Q3 and Q1. Q3 is 92.5. Q1 is 86. I'm going to subtract them from each other. 92.5 minus 86. My IQR is 6.5. The interquartile range is quartile 1 and quartile 3. And today that'll make more sense when we go over it. Letter F. If I accidentally left out one day where the high temperature was 127 degrees in Hawaii, that's called a volcano. Which statistic would change and why? Which part of my data is going to change? What? Okay, the range will definitely change. What else will change? The what? The mean. The mean will change. The median will stay as is. I mean, you know, the only reason the median is going to change is because you've added more data, and so your middle has moved. But the mean itself will be influenced the greatest by some outlying number. And then the range also that's a good call. If a right skewed distribution of data, which is central tendency statistic would be the greatest. So if I had a right skew of data, so if I had this, which line up there is the mean, blue or green? Green. What would the blue one be? The median. Okay, if it's skewed right, the mean gets tugged the direction that the longer tail is. if a set of data is symmetric and unimodal, so a bell curve, then which would be larger, the median or the mean? They're the same. Okay? They're equal to each other. Number 7, assume that Denver Broncos usually score a lot more points. There are a couple games that they score just a few. What shape is the distribution? What do you think? So Broncos score lots and lots and lots, but there's a couple of games they only score like 3 points. What's the, skew what? Skew right? Skew right or skew left? Longer tail to the left or longer tail to the right? Yeah. It's going to do that. So the small scores, the large scores, you're going to have the average on. Then you had a couple scores that were low, so it's going to skew it to the left. So of this, I have a black line, and then I have a red line. Which one is the mean? The red. The tail to the left will pull it to that way. Okay? Number 8, we can do it on the calculator, no problem. So I'm not going to worry about plugging it in. Number 9 says, let's assume the previous data, I forgot to enter a score of 81. I put it back in, circle the measures that would change a lot because they're not resistant to such extreme values. I forgot to score. I put it back in, circle the measures that would change a lot because they are not resistant. So the mean would change, the range would change, the IQR could change, or well, not necessarily. So the one that would change the most would be the mean if you have an outlier. And then use the summary of the following for the 2 classes worth of test data. We have 3 periods now. So we have an average of 2 of the periods being 80 and 1 being 85. We have a median of 84, 80, 85. And we have a standard deviation of 12, 5, and 0. So which set most likely looks like a bell curve? First, second, or third period? Which one's going to look like the bell curve? If it's a normal curve, what are both the same? Mean and median. So which have the same mean and median? Second period. The second period is going to look most likely like a bell curve. Which one's going to be skew right or skew left? Excuse me. Skew left would mean that the mean is to the left or less than the median. So first period, you're right. Right? Which data set must have a high score of 85? Question. Which data set must have had a high score of 85? The second period could have a score of 85, but it doesn't have to just be 85. I would say third period, you don't have a standard deviation. The mean and median are the same thing. So what do you know about the tests that have a third period? There's no standard deviation. What do you know about the test in third period? They're all 85. So that's got to be the only one that would say that it absolutely has to be the highest score. Which data set likely has the greatest interquartile range? Ooh, I'm going to come back on that one. Because we don't have enough information to get there yet. Which data set represents the best scores on the test? Bless you. The third period has just everyone got an 85. Which data represents the best scores on this test? I'd say first period because the standard deviation is 12. That means your data is way spread out. So they might have the best scores. The average might not be the best, but they might have the highest. And which data set probably had the most scores of 90 or better? God bless you. And I think that would also have to be first period. Okay? And then we'll move on. All right, so again, we're looking at data. We're going through data. We're talking about data. There's ways of representing data. The IQR is a new piece of information. So it's the interquartile range. So when you, God bless you, it's a sneezy class right now. When you do the IQR, it's going to be your Q3. So you're going to get Q3 from your calculator minus Q1. Again, that's going to come from your calculator. And you get that by plugging your stuff into the stat, into a list, do the one variable statistics of that list, and it'll tell you what the quartile 3 and quartile 1 are. Subtract the two from each other, you get the interquartile range. Okay? So, the interquartile range, God bless you, the interquartile range does this. It has 50% of the data within it. Okay? So, 50% of your data falls in the interquartile range. Half of your test scores would fall into that range. Now, if I want to find that data is too far away, so it's an outlier, you ever think that sometimes you might have that one kid in class and like the class average is like a 65%, and then you take out the one kid who aced it and the average dropped to like a 48%? That kid influenced the average because you had a kid that might have been too smart to be in that particular class. It'd be like if I were to take you guys and say, all right, we're going back to 4th grade math. Or like, you know, all you seniors that were here during CMAS, imagine you went down to the 4th grade and took the CMAS there. They were like, man, what are they doing there in Cherry Creek High School in that district? I got really good 4th graders. None of the seniors showed up at Creek. All right, so sometimes you might have an outlier. So if you want to know if you have an outlier, if you want to have an outlier to the left, it's going to be Q1 minus 1.5 times the IQR. And then if you go to the right, it's going to be Q3 plus 1.5 times the IQR. Order of operations would suggest to do what first? Do we add first or do we multiply first? Add. Do we subtract first or multiply first? Multiply. So order of operations, so you got to do that. So we can do this in a moment. I'm already there. What should I do? I want to cover one last thing. We've already done it. I just haven't made the data happen. We've already done it. We just need to put it into a graph. I'm going to show you how to do it by hand first. Then I'm going to show you how to do it on a calculator. Sound good? Can I do it? You with me? Does anyone need to poke your neighbor in the eye real quick? Okay, if you do. Huh? All right, let's just go off. let's go off some temperatures. Let's say here in this area, the past 2 weeks had these temperatures as a high temperature. One, two, three, 4, 5, 6, 7, 8. Yeah. 11, 12, 13. All right. Let's say those are the high temperatures, the ones that have a 208. That means that multiple days for that. Okay? So first thing when we take our data, we need to list it from least to greatest. So what's my least temperature up there? 12. And how many do I have? 2. Still with me? So I've taken care of this. Then what's my next least temperature? How many times? 2. Then what? 26. That's a once. Then what? 29. Then 30 twice. And then 31 twice. 46 twice. 70. Do we have them all? We have 2, 4, 6, 8, 10, 12, 14 numbers, 2 weeks worth. 2, 4, 6, 8, 10, 12, 14 numbers. Good. Okay. So there's some things that we're going to know how to find right now, real quick, without doing a whole lot more math. What is the range right now? 70 minus 12. Help me out. You got a calculator? Do 70 minus 12. It's like 58, right? Okay, that's okay for the range so far. Is everyone still with me? Other things that we know how to do. What is my minimum? 12. What is my max? Okay. That's just a way of looking at the data so far. If I wanted to find the average, I would have to add them all together and divide by what? 14, because there's 14 pieces of data. Somebody got a calculator? Add those up real quick for me. Cell phones go away, please. 12, 12, 16, 16, 26, 29, 29, 30, 30, 31, 31, 46, 46, 70. How much? 424. And 424 divided by 14 is how much? Yeah. 30.28. Okay. So all of my scores added together, then divided by n, the number of scores, we found the average to be 30.28. Now I want to find the middle of the data. There's 14 numbers up there, right? So I go here, here. Am I at the middle yet? I'm going to go here, here. Am I at the middle yet? I'm going to go here, here. Am I at the middle yet? I'm going to go here, here. Middle yet? Here, here. Middle yet? Here, here. Uh-oh. What's my median? How much? 29.5. How do I represent the median with X? Yeah, X hat.
That's a real name.
I'll go with it. 29.5. Are the mean and the median about the same? Okay. They're pretty darn close. Okay. Let's split the screen up. See if we can figure out a little bit more data. All right. So I'm going to do this. I'm going to plot my minimum data, that's 12. I'm going to plot my maximum data, which is 70. And I'm going to connect the dots. You with me? So I just kind of made a number line. Now, supposedly it should be equally marked off. So I'm going to take my median, which is x hat, and I'm going to call that 29.5. So is 29.5 closer to 12 or closer to 70? Closer to 12. So we might call 29.5 right there. That's my median. Median is also sometimes referred to as Q2. Your calculator won't show you Q2, but just realize the median and Q2 are the same point as far as data goes. Now what I want to do is I want to find Q3. Q3 is the middle of the upper portion of our data. So let's do this. So I'm going to go here to here. So I'm going to go 29, 30, or excuse me. 30, 30, 31, 31, 46, 46, 70. 70 kind of fit there. The middle, coming in, coming in, coming in, 31. 31 is the middle of my data. So I have 31 about here. I want to find Q1. Q1 is the bottom of my data. So I'm going to take the bottom portion of my data and include that. So I have 12, 12, 16, 16, 26, 29, 29. Come to the middle. What is my IQR right now? How do I find IQR? Yeah, so the IQR is going to be Q3 minus Q1, which is going to be 31 minus 16, which is 15, I think. Is that right? So that's a box and whiskers graph. The amount of data that is between Q1 and Q3 is half the data. Okay? So it goes like this. Over here represents 25% of my data. Inside here represents 25% of my data. Right here represents 25% of my data. And out here, 25% of my data. Even though they're different sizes. Absolutely. So you might come across a problem saying the interquartile range accounts for how much of your data? 50%. Below the median is 50%. Above the median is 50%. So if you talk about it this way, below the median is 50%. Above the median is also 50%. So let's see if we have any outliers. By looking up there, do you think we have anything that's an outlier just by 70 could be. Seems like it's pretty far out, right? Far out, man. So what did I say the equation was to find the outlier? So I have Q1 minus 1.5 times the IQR. And that's to the left. And if I want to find the outlier to the right, okay. Most of them you'll get. I'll throw them to you. All right, and there's no reason to have them memorized because in statistics, I think you'll be able to do that. All right, so Q1 is what? 16 minus 1.5 times the IQR, and the IQR we found is to be what? 15. Could somebody do that for me real quick? So just on your calculator, you go 16 minus 1.5 times 15. It'll do the order of operations. While you're doing that, I'll write this one down. So Q3 is 31 plus 1.5 times the IQR, which is 15. And somebody do the other one too. Negatives. This is negative 6.5. Okay. Can we go the other way too, please? 53.5. Okay. So 53.5. Probably right in there somewhere. That might be off by a smidge. So is 70 to the right of 53.5? So 70 is indeed an outlier. Okay? A lot of times an outlier you want to eliminate from your data. It's like a freak show situation. Okay? Shouldn't have happened. It's the anomaly that you don't want to take place. All right. So, the only homework I'm going to give you is this take-home quiz. Is that all right? I hope you do well on a take-home quiz.